Welcome students. Let's go for today's problem. Electric field in components in figure are Ex equal to alpha x to the power 1 by 2, Ey Ez equal to 0. Let us focus to this point only. That means only x-axis E exists. Y-axis and Z-axis, that means these four faces, there is no electric field. This is clear. Let's say only these two faces will face electric field. So flux will be there only due to these two faces. Now again, if it will be uniform electric field, net flux would be 0. So what are the lines will enter? That amount of lines will leave. If it is parallel, so there is any chance that it will cancel to each other. Entering means minus, leaving means plus, they will cancel to each other. But here problem is, it depends on x. That means with respect to position, electric field varies. So what is that? Alpha x to the power 1 by 2. That means with respect to position, electric field increases. Okay, how many sides are there? Let us find out. Only two sides electric field will face. In these directions, electric field is there. One is left side, another one is right side. Okay, let me solve about first left side. Then I will go for right side. So what is left side electric field? Left side electric field in this position x equal to a. So for this face x is equal to a. Right side x is equal to, from origin it is a, side is also a, that means x is equal to 2a. So in this case, alpha x to the power 1 by 2, alpha is a constant, forget about that. So it will be alpha a to the power 1 by 2. And what is the value of a? At last we will put, that is 0.1. I will tell the process, you will solve it. Right side what will happen? ER. So what is that ER? Alpha 2a to the power 1 by 2. So here alpha 2a to the power 1 by 2. Now what is area vector for the left hand side? Area vector is towards the left. That means this is the perpendicular direction, which is outward direction. So for this case, area vector is minus I cap. What is the area? Side is A. So I will write here minus A square I cap. Now I will go for the right hand side. Area vector direction is towards right. That is normal is outward. Towards right is positive x-axis. Area is A square. So area vector towards right DSR vector equal to, I will write it here, this is nothing but a square positive I cap. Now I got E and DS. So what is the next step? Next step is nothing but flux for the left hand side, flux for the right hand side. For the remaining four faces, flux is 0. So I will write, let us go for the left hand side flux, that is nothing but E dot DSL. Right hand side flux is nothing but similarly E means this is ER dot DSR. Now the question E left hand. E left hand is minus alpha a to the power 1 by 2. And obviously it is vector, means its direction is, it is given along x-axis. So I will write it I cap. This is also I cap. So I will write it here I cap dot DSL. DSL is minus a square I cap. Now similarly flux in right hand side will be equal to, I will get here ER. ER means for right hand side alpha 2a to the power 1 by 2 I cap dot a square I cap. Now if I will solve it, I got left hand side flux equal to alpha AQ. I dot I is 1 minus, so I will write minus alpha AQ. And right hand side it will become what? This will be I dot I is 1 plus, so I will write it here alpha root 2 a square a to the power 1 by 2. So it will become a to the power 1 by 2 plus 1, that is 3 by 2. Am I right? Let us check it here. 1 by 2 plus 2. So it will become, I think it is 5 by 2. Please check it. Now what is the net flux? So the net flux will be equal to, for 6 sides, remaining 4 sides, all fluxes are 0, plus left hand side flux plus right hand side flux. Now after adding this, you will get net flux. Then applying Gauss law, what you will get, that is flux, net flux equal to Q by epsilon naught. So from here you will get Q equal to flux into epsilon naught. After getting that, you will get charge. Thank you. So I was asking here, if the charge is at the center, what will happen? If charge is at the center, the net flux will be Q by epsilon naught for the total. For one side, it will become, for 6 side, it is Q by epsilon naught. For one phase means Q by 6 epsilon naught. This was asked in 2017 CBSE board exam. Now for 5 marks, so think how can you answer it. Now the question, if it is at the center of a phase, then what will be its flux? For total, for single phase, you have to answer it according to that. Let us think for the total. How many cubes required to, since it is half is inside, half is outside, another cube is required to keep it totally inside. That means 2 cubes required to keep it inside. That means half of the charge is inside. That means I will write the net flux will be equal to Q by 2 epsilon naught. Now if I'll go for a third case, think it similarly. How many cubes required to keep it? 1, 2, 3, 4. Just think that in 3 dimensions. This is 1/4 of the charge is inside. 1/4 of the charge, because 4 cubes required to, in 3D try to imagine. So I will write it here. This is Q by 4 epsilon naught. The phase side, you have to think for individual phase how many charges or how many flux. Now for the fourth in corner, if I think that this is a cube, so first below half required 4 cubes, upper half required another 4 cubes, so 8 cubes required. That means 1/8 of the charge is inside this cube, so the flux will be equal to Q by 8 epsilon naught.